Hello, everybody. This is Dr. Zhang. Uh, this video is for chapter 19 of General Physical Science. So you already have this PowerPoint slides on Blackboard. What I want to do in this video is give you some outline of important points of chapter 19. Another very useful text document is the textbook you have electronically through website. So this chapter is called the atmosphere. This is basically one of the two chapters we have for our earth science class section. And we have 5 sections for this chapter. So it's easier to see from this. So it's a pretty long chapter, but for each section, we only need to know a couple important points. The first section is about the composition and structure. So the first thing you need to know, okay, you can read everything. It's not that difficult to read every slides here and understand the basic definition. Okay, but I'm gonna just point out some important thing. So in the first section, the most important thing is the composition of the atmosphere. So we know the most important composition we have are nitrogen and oxygen. And then after that, we have argon and carbon dioxide. So their percentage can be seen from this chart. Nitrogen has about 78%, oxygen 21%. Together, that's 99%. So that's the majority of our atmosphere. And then carbon dioxide, argon, and other things are just a very small portion of it. And this is a more detailed list of all this fraction. Notice that all the fractions here refer to the volume, okay? So these are the four main composition. Other than that, we have some other things as well. So one important thing to keep in mind, so there's some carbon monoxide in the atmosphere, but that's not enough. The most important thing for atmosphere is called the atmospheric equilibrium. Okay, this is basically a process of going back and forth between carbon dioxide and then oxygen. So first of all, there's a process called photosynthesis, okay, which is produced by done by the plants. It consumes carbon dioxide and then produce oxygen. On the other hand, uh, we know animals consume oxygen and produce carbon dioxide. For example, we breathe in oxygen and we breathe out carbon dioxide. So these two processes is doing exactly the two opposite thing. So as a result, there's an equilibrium. And there's also some nitrogen equilibrium as well. But the most important one I want you guys to understand to know is going from carbon dioxide to oxygen and back. This is there's also like a talk. They can talk about the density of the atmosphere, etc. Okay. And another thing we need to know is this is the composition, right? So what about the structure? Okay, so there are two ways to talk about to divide the atmosphere. One is dividing them into this 4 different layers: troposphere, stratosphere, mesosphere, thermosphere. Okay, uh, the troposphere is the one that contains 80% of mass. And roughly speaking, there you can see from this graph, okay? So this graph gives you, this is the height of each layer you have, okay? The troposphere is at the bottom, okay? This is the height from the surface of the Earth. As you see here, the way they divide them is such that the temperature in troposphere is actually going down, okay? And then after that, and this troposphere is actually, as you increase the height, temperature goes up, and then mesosphere goes down again, so it goes up again. So you probably heard that on the surface there, the higher you go, the colder it's gonna be. That's not always true. Okay, it's actually only true in this layer and this layer. Okay, but just because see the height here is like a 17 kilometer, and then the tallest mountain on the surface of the Earth, Mount Everest, is less than 10 kilometers. So basically, it for all the mountains, it's correct that you go up, the temperature decrease. Okay. Okay, another way to divide the this talk about structure is using this kind of ozone sphere and ionosphere. Okay, so the ozone sphere is a different way to separate. So this is actually the has a great the ozone is a great concentration oxygen 3. Okay, it's not the normal oxygen molecule, it's oxygen 3. Okay, so it's actually roughly equivalent to the stratosphere, which is on this layer here, the second layer in this part. It's called the ozone layer. Okay, the ozone layer is actually very important for the atmosphere because of the kind of it's importantly to uh, balance the UV radiation and oxygen molecule. Okay, so basically you have one oxygen atom plus oxygen molecule to get this O3 molecule. And then there's a ionosphere, a region between 70 and 700 kilometers. It has a lot of ions. Okay, so basically, because of that, you have there are different reflection because of ions, different kind of different electromagnetic waves can be reflected from different sublayers of ionosphere. Okay, that's the most thing I want you to understand in the first section. Okay, now the second section we talk about the energy of the atmosphere. Okay, again, you should read everything, but the most important thing I want you to understand is the so-called greenhouse effect. Okay, okay, what is the greenhouse effect? It's actually a very important effect. So basically, when the sunlight goes, so the atmosphere surrounding the Earth is kind of like a greenhouse. Okay, that you grow plants in like with like a glass ceilings or walls. So when the sunlight goes in, all of them can reach to the surface of the earth or into the greenhouse. But when it really out, because there's an atmosphere layer, and in this case there's a glass ceiling. Okay, only specific kind of wavelengths light can be going out. It's infrared radiation. So a lot of these are actually being absorbed. Okay, so this actually is an effect that keeps the surface of the Earth warm. Okay, just like in the greenhouse, it's warmer normally. Okay, than outside. That's because a lot of radiation coming in cannot be getting out. Okay, and certainly uh, this this greenhouse effects also kind of affect the temperature of the Earth. For example, you probably heard about global warming or something. That's partially related to the greenhouse effect. Okay. Another thing I want you to understand is the something called Rayleigh scattering. Rayleigh scattering. Okay. Uh, basically, the atmosphere can scatter different kind of lights, uh, and the amount can be scattered is proportional to 1 over lambda force, where lambda is the wavelength. So basically, the shortest wavelength is the one that's scattered the most, and then that's basically the blue light. Blue light. That's why when you look up, most of the times, in the sunny day, you see the sky is blue. That's basically it's not really sky is blue. It's the atmosphere looks blue because of the radiation, the Rayleigh radiation, or Rayleigh scattering. Okay, so these two things are the most important for section 2. Now go to section 3. Okay, This is about measurement and observation of on atmosphere. Okay, so there are basically a couple of physical quantities that you need to know for the third part. So these are temperature and humidity and pressure. Okay, and there's also wind speed and precipitation. Well, we already know temperature pretty well, right? That's like a same thing as we talk about when we talk about thermal. The pressure is basically force per unit area. It's given by force divided by area. Okay, and on the surface of the Earth, what we call the pressure of the air is one standard atmosphere pressure, and this pressure, if you use the unit of pounds per inch square, is 14.7. Okay. Well, if you use another very commonly used unit is uh, mercury height. Okay, so basically the pressure of the atmosphere can support up to about 76 centimeter of mercury height. Okay, so that's another unit. So see, the ISI unit pressure is in Newton per meter square. It's about 1.013 times 10 to the fifth. In the British system, it's what 14.7 pounds per inch square. And then if you use the mercury height, it's about 76 centimeter. Okay, so these are different units for atmosphere pressure. And we also want to talk a little about humidity because this is a kind of a new idea for us. Okay, so when we talk about humidity, there are two concepts we need to know. First of all, is absolute humidity. Okay, that's the amount of water vapor in a given volume of air. The common unit we have is a grains per cubic meter. And then there's also relative humidity. So that's like you take uh, the relative humidity is calculated by the absolute uh, humidity divided by the maximum okay, sorry, the actual moisture content divided by the maximum moisture capacity and times 100%. So for example, if you have the moisture content reached to the maximum possible value, then your relative humidity reached 100%. That's be the highest you can have. Okay, and well, this maximum moisture capacity, meaning that how much water vapor the air can take, depend on temperature. In general, the higher temperature you have, the more water vapor the air can carry. Okay, and well, this is actually a very useful uh, graph for every life. So this tells you the relative humidity and then air temperature case. So basically, as you see here, when it depends on, see, this is the actual temperature, but the number here is showing you the temperature you feel. Okay, so as you see here, when the humidity, relative humidity is 70%, the temperature you feel is the same as the actual temperature. So 70% is really kind of like a perfect humidity. Okay, if you have high humidity, okay, if you increase humidity, you see that you feels like hotter. Okay, now especially when you get into like the temperature I mean, itself is pretty high. Okay, see this becomes really hot. Okay, and when you have dry humidity, okay, I mean dry air, then it feels colder. Okay. Okay, another related point concept called dew point. Okay, this is the temperature in which a sample of air must be cooled to become saturated. Okay, so this is the temperature. So basically, as we explained, the maximum air capacity depends on temperature. The smaller temperature you have, uh, the less amount of water vapor air can carry. So the dew point basically is the point is the temperature in which the air is saturated. Okay. So if you go below, if the temperature actually is below dew point, then you have a more, I mean, the air cannot take that much water, so the water will come out. That's what you see in the morning on the grass. You see the dews because of that. Okay, I think that's mostly what I, there's some specific calculations for doing this, but using this table, but uh, I don't think you guys need to do that because we don't have any homework problem or quiz to talk about that. I think yeah, that's basically what I want to understand. What I told you just before. Okay, now section number 4 we have air motion. Well, what is air motion? Basically, that's wind, right? That's essentially wind is air motion, nothing else. Okay, so how do we have wind? Okay, I'll just show you a very simple graph here. Okay, let's say for example in this case, okay, uh, when okay in the day, okay, the land heats up faster than the ocean. Okay, so there higher temperature here. That means when temperature is high, the air kind of expand, so the air becomes less dense, so the air will go up. Okay, then the corresponding, I mean, the nearby air from the water to the sea level will come to compensate. So they have this convection, okay, cycle. At night, it's the opposite. At night, the ocean is warmer, so the air on the ocean will go up, and then so they'll have the opposite convention. So this give you wind on different directions. On day it going this direction, night going that direction. Well, this is just a simple example. In reality, you could have a wind going different directions depending on all different kind of factors. Okay, this is just one example. Okay, well, there's other things like Coriolis force and et cetera, et cetera. You feel free to read them. But the most important thing I want to understand is this simple airflow. Okay, how the air flows. Okay. Okay. So the last section we have here is a cloud. Okay. It's kind of an interesting section as related to the lab for module 8. And for the cloud, I just want you guys to know some the classifications. Like there are different 4 different types based on the different form. And also you can also classify cloud depending on the height. High cloud, middle cloud, and low cloud. Okay. So this is what it looks like. This different kind of clouds that we just talk about. Let me see where it is. Yeah, it's right here. Okay. So okay, I think that's all I want to talk about. In the lab, you need to do something about cloud. Take some picture of cloud and then tell us what kind of cloud you think it is, and etc. Okay. Okay. That's all I want to say about chapter 19. Okay. Let me stop recording.